Is the quantum observer effect simply psychological bias? Have you ever wondered if the way we observe things can actually change what we see? This question leads us to the fascinating realm of the quantum observer effect. So, is this effect just a trick of the mind, or is it something more tangible? The quantum observer effect is a real physical phenomenon. When we measure or observe quantum particles, their behavior changes. In quantum mechanics, particles like electrons can act like waves, existing in multiple states at once. But once we measure them, their wave function collapses and they settle into a specific state. This is not just about how we perceive things, it is a measurable change in the particles themselves. A classic illustration of this is the double-slit experiment. When electrons travel through two slits without observation, they create an interference pattern, acting like waves. However, if we place a detector to see which slit an electron goes through, the interference pattern disappears. The electrons behave like particles, going through one slit only. This shows that the act of measuring alters the outcome, proving that observation affects the system itself. Why does this happen? Measuring a quantum system involves interacting with it, like shining light or using detectors. This interaction disturbs the particles, leading to the observed changes. It is not our consciousness or psychological bias that causes this effect. It is the physical interaction that takes place during measurement. The idea that just thinking about something can change reality is a misunderstanding of quantum theory. From the perspective of strange experiments and quirky results, this phenomenon is captivating. It challenges our everyday understanding of reality. At the quantum level, particles behave in ways that seem odd and counterintuitive. The observer effect highlights how the act of looking can change what we observe, but the reason lies in the physical process of measurement, not in our minds. In practical terms, the observer effect has important implications for developing quantum technologies. Fields like quantum computing and quantum cryptography relying on understanding how measurement works. This also raises philosophical questions about reality and the limits of human knowledge, making it a key topic in strange scientific experiments. So, the next time you think about the observer effect, remember that it is not just a psychological bias. It is a fascinating physical phenomenon that reveals the quirky nature of the quantum world.